Good evening, dear friends. This is my second video on chapter 11 constructions. Now, today we are going to start the exercise examples for exercise 11.1. Your first example is to divide a segment BC 6.5 centimeter into the ratio 4:3. So we have to divide the segment BC in two parts, 4 and 3. 4 parts one side and 3 parts one side. So total 4 plus 3 is equal to 7 parts. Okay, now let's start. Draw a segment BC 6.5 centimeter. Okay, so this is segment BC. .5 centimeter. Draw one ray BX which makes acute angle with segment BC. This is the acute angle. CPX is an acute angle that is less than 90 degree. Now take compass, take some radius, not very big, not very small. Now remember that we have to divide this BC into two parts in the ratio 4:3. That is 4 plus 3 is equal to 7. So we'll take 7 equal parts on ray BX. See this how we can do it. Take the center B and draw arcs. Arc number 1, like that 7 arcs you draw. 2, 3, 4, 5, 6, and 7. Label it as B1, B2, B1, B2, B2, B3, B3, B4. These are the equal segments. B4, B5, B5, B6, and B6, B7. See that B1, B1 is equal to B1, B2 is equal to so on, is equal to last one is B6, B7. Now draw segment B7C. Join C and B7. See that. Take ruler and draw a segment B7C like this. As in last video I showed you how to draw a parallel line. We are going to draw the parallel line from B4. There are 4 parts we have to take up and 3 parts down. So B1, B2, B3, B4. At B4 or from B4 we have to draw one parallel line to B7C. So we have to use the congruent angles property. See how. Now taking compass, keep the compass at B7, or taking the center B7, draw one arc. See here. Draw one arc. Taking this same radius from B4 now. We have to draw the parallel line B4. So take the center B4. Keep your compass on B4 and draw some arc. Same way. Okay? Same distance from B7 and from B4. Now keep the arc here. Adjust your distance. Your radius should be between these 2 points. See here. And draw one arc. Taking point where this arc intersects the ray, same way we have to cut this arc. Now join this point with B4, the point of intersection of this arc with B4. So keep your ruler such a way that you can draw a line correct. So this will be a parallel line from B4 to BC. Name this as point D. You can give any point, you can take any point. You will see that BD is divided into four ratio. BD is 4 parts and DC is 3 parts. So D divides segment BC into 2 parts, that is 4:3. Now these are the steps written here for construction. In the examination, no need to write steps. This is for your explanation. Let us see again. First, draw ray segment BC 6.5, given ray, whatever the distance is given, this one. Now we have to divide the ratio in the ratio 4:3. So total we have to take 4 plus 3, 7 parts. So we have to draw from B, we have to draw one ray and divide this ray into 7 equal parts, that is B1, B12 and so on up to B7. 4 plus 3, 7. Then draw segment B7C. From B4 draw parallel line, that is B4D. This line is parallel to B7C. So this D divides the ratio segment BC in the ratio 4:3. I hope that you have understood. Now what is the explanation behind it? This is the justification of the construction. Now observe this one. This property you may not be knowing it. Later on I will explain you. This property is called BPT. Now this is a triangle BCB7. In triangle BCB7, B4D is parallel to B7C. So what happens? Due to or because of basic proportionality theorem, this parallel line divides the segments in the equal ratio. So we have divided this BX ray into 2 parts, that is 4:3. So this parallel line will divide segment BC also in ratio 4:3. This is called BPT, basic proportionality theorem. So let me explain you again. In triangle B7C, B4D is parallel to B7C. Hence B4 upon B4 B7 is equal to BD upon DC. Now as B4 upon B4, B7 is 3 upon 4, hence BD will be also equal to 4 upon 3. 4 upon 3. So hence BD is to DC is equal to 4:3. Practice this nicely as it is explained. You will be able to understand. Construction number now 2 I will show you tomorrow. Let me explain you the similar figures. So these circles are similar. Similar figures means looking alike, looking same. Size may not be same, but shape is same. So all the circles are similar to each other. All the squares are similar to each other. We have to concentrate on the property similarity of triangles. In this figure, I have shown you a triangle ABC and triangle PQR. These are two similar triangles. So what are the conditions for the similarity? There should be 1-1 correspondence between the vertices. ABC corresponds to PQR. That is, A corresponds to P, B corresponds to Q, and C corresponds to R. So if the two triangles are similar, then these three conditions should be satisfied. Angle A should be congruent to angle P, corresponding angles. Angle A corresponds to angle P, and these are congruent angles. These congruent angles are shown by identical symbols. Angle B is congruent to angle Q, and angle C is congruent to angle R. And the ratio of the sides, that is AB upon PQ, how to find out? AB upon PQ is equal to BC upon QR, BC upon QR is equal to AC upon PR. So this is called ratio of the corresponding sides, and these corresponding angles are equal. If these conditions are satisfied, then these two triangles are similar to each other. We can write like that: triangle ABC is similar to triangle PQR. This property we are going to use in next construction. So today's homework I am giving you based on the explanation of the triangle. Draw segment AB is equal to 7.5 centimeter. Divide segment AB into the ratio 3:5. Remember now this AB should be drawn 7.5, and you have to take ratio 3:5. Mean total 8 parts should be there. 3 plus 5 is equal to 8 parts. Repeat the construction which is shown to you, and tomorrow I will show you the next one. Okay guys, thank you very much.